Humanity, ignorant in bliss. We go about our lives unaware that in the depths of space lurk invisible monsters. Destroyers powerful enough to tear apart our sun and leave our Earth a shattered, burned-out ruin. You are about to enter the world of the universe's ultimate killer. We will be there when the monster is created. This is the story of the power that may one day destroy us all. The black hole.
Watch this. I'm gonna circle this right in here. You seeing that moving the other way? Look at that. Right in that spot. So what's going on here? In my opinion, there's something there. The sun's reacting to it, and that's why this energy is going the wrong direction. Okay, it's either giving or robbing energy from the sun here. Okay? That's what's happening.
Take a black hole, drive gas into the galactic core. That gas descends into the waiting black hole's gravitational well and gains incredible speed on the way. It is swept up into a raging whirlpool around the black hole that we call an accretion disk, where its energy of motion is turned into heat. The heat glow of the accretion disk is so bright that we can see. The exact appearance of this phenomenon depends enormously on our viewing angle. Looking down onto a bright accretion disk, we see all of its glory. But viewed side on, that disk is obscured by a thick ring of dusty gas. Then, we only see hints of the central monster because it lights up gas in the surrounding.
And we're also seeing, and I'm going to show you something. This is actually probably the better one. You guys can, if you look right in there, watch it. You can see it moving the wrong direction. Okay, and again, I said this yesterday. The sun that's the surface of the sun. So for this energy to be way out here and to go back the other direction would almost take something there to help it. Okay? But for it to go out this far and then come back is very, very odd. That's all I'm saying. If it can get escape velocity, that's when the ejection actually happens. That's when you'll see the ejection.
If something goes up fast enough, it can escape the immense pull of our sun, the force that holds the planets in place. But there is one object out there whose pull is so powerful you can never escape, no matter how fast you go, not even if you travel at the speed of light.
So, and you got, again, watch right here. Okay, see it moving backwards? So, this is the last imaging we got from this. Now, we can still go over to ISWA and look at this view. It's updating there. But they're not letting us see this view, okay? Why? If they have the data, why can't they input it to this and let us see this, okay? I mean, there's no reason not to, unless they don't want us to see something.
An accretion disk, where its energy of motion is turned into heat. The heat glow of the accretion disk is so bright that we can see a lot of it never makes it below the event horizon. Some is converted directly into energy and radiated as light, and this same light drives powerful winds of gas back out into. Some of that gas can also be swept up and collimated, channeled into jets that erupt from the poles of the. This may be due to the magnetic field of a rapidly rotating black hole, but the jury is still out. The exact appearance of this phenomenon depends enormously on our viewing angle. Looking down onto a bright accretion disk, we see all of its glory. But viewed side on, that disk is obscured by a thick ring of dusty gas. Then, we only see hints of the central monster because it lights up gas in the surrounding. However, if such an edge has powerful jets, we see them filling intergalactic space with beautiful radio plumes. Oh, and if one of these jets happens to be pointed directly at us, then we see strange effects due to the near light speed motion of the jet material. In an effect called relativistic beaming, the light from the jet is vastly magnified. These rare cases are called blazars. So, When a black hole feeds and blasts energy into the universe, what we see depends on its orientation, whether or not it has a jet, the power of the accretion disk, and a few other properties besides.
Okay, this is the last imaging that we got. Right in here. Okay, if you look close enough, guys, that object is there. It's not moving. It's not going out with this energy. It is there. I mean, look at that.
Meet the monster. This is a black hole in action. It is tearing apart a star that is strayed too close. Anything that comes near is destroyed.
It's hard to believe anything could be powerful enough to destroy something as big as a planet or a star, but it's true.
Let's take a closer look. Put a black hole near something and immediately it starts ripping it apart.
There's a star in there. Could just as easily be our sun, and it is being pulled apart by a black hole. On this scale, our Earth would be no bigger than a pebble. The shocking thing is how small the black hole is. The black hole itself is right at the center of the disk. It's tiny. It's 1,000,000 times smaller than the star. Just look what it can do.